Okay, welcome to the tutorial series on Dominator. I feel like when you say Dominator, you just kind of gotta say it like that, right? It's got that that energy to it. Okay, so what is Dominator? So first of all, it is a fast, or I guess we have to say blazingly fast, Rust front-end web rendering framework. But the truth is, it's really kind of two different libraries, both of which were created by Pawan, I hope I'm pronouncing that right, who was a former member of the Rust WebAssembly working group. And specifically, he did a lot of work on like the async futures, integration with the web ecosystem. And both Dominator and futures signals, which is the kind of secret sauce of this whole thing. So both of those like really build on that low level integration between like promises and futures and streams. And we'll get into all of that. But the whole ecosystem really is a functional reactive programming rendering framework that takes these signals, which come from future signals, and ties them to the DOMs. You can like render web content with it. And that's the essence of like what it's all about. And because it's built on like low-level primitives and very tight integration between WebAssembly and the Web API, everything is really kind of like as fast as it can be. And it very much follows the mentality of Rust in general, which is, just kind of like zero cost abstractions. And if you were to do the same thing with a lot of unrolled imperative manual code, you would end up basically with like the same cost. Now, that is very much like a Rust way of thinking about things. And it does end up being a little bit verbose. Like we'll see that a lot of the syntax is, you have a lot more explicit cloning. You have a lot more, calling multiple methods to like kind of do something that, you might think you can do with one method, but you wouldn't want to do it that way everywhere. And so, Dominator and future signals kind of gives you the tools to make those explicit decisions. And it's very clear like where the costs are. We're going to go way deeper into that, especially as we get into like signal extension and signal vec and all these combinators. And I know that's a mouthful. If those words don't make sense to you yet, they shouldn't. Like that's why you're here. As we dig into all of that, we'll see like the explicit examples of where these trade-offs are made. And I think that's a key word to keep in mind also throughout this series, trade-offs. And I think we will generally be comparing Dominator to React just by way of kind of picking probably the most popular web rendering framework today and seeing like where Dominator and future signals makes different decisions in terms of the trade-offs. But the recurring theme is definitely going to be that we prefer explicit insight into where performance and data flow and like how these things are actually happening, and so that we can control it, as opposed to let's say maybe like an API that leans towards having you type less characters on the screen. Right now, I'm being a little cheeky about that, but it really is the truth. That Dominator is very verbose compared to, let's say, React, but it's much more clear and powerful in terms of giving you the tools you need to render web applications and understand how it's actually working. Dominator does not have a virtual DOM or any sort of diffing engine. And the way that works is you wire the thing that's changing to the thing that you want to change, right? And that really is a big difference. I mean, like, let's say, for example, React, they give you like a very clean declarative API. And when your data changes under the hood, it has to do all these diffing steps to kind of figure out, okay, now what do we update on the screen? Whereas with Dominator and future signals, you just do that yourself. You reason about how your data flows and where you want it to affect the UI. That said, it piggybacks on Rust itself, right? Like Rust is a fantastic state management library. I mean, it's a language, but with enums, with traits, with pattern matching, with futures and streams. You have a aspect of time changing, and these language features give you all the power that you need to reason about your state. You don't need like another library to deal with that. And we'll see like kind of where each part of this fits together, right? Because there is the part of it that's just pure Rust. There's the part of it that's Dominator, and there's the part of it that's futures signals. And you might wonder like, okay, we have all these pieces. How do we actually interact with the web API, like audio context and canvas and all these sorts of things? And that is another angle here of WASM bindgen. And we haven't really spoken about that yet. It's a little bit outside of the context of Dominator exactly. It applies to any sort of Rust, WebAssembly, front end framework. And it is a topic unto itself, but Dominator doesn't get in the way. Like if you want to be able to reach out and, even with third-party libraries, if you want to interact with, any other NPM, library that you bring in, you can do that. And it's through the WASM bindgen interface. And you can also write your own JavaScript bindings, which is sometimes very useful. And each of these really are separate concerns, right? Like the pure state and business logic and memory management, even all of that is like the domain of Rust. Whereas interop with the web is WASM bindgen, and rendering to the screen is Dominator, and values changing over time and kind of like, combining together is future signals. And each of these are completely separate domains. And by keeping them separate and thinking about them independently and how they interact with each other, it makes it much easier to reason about like code at scale, right? Again, we will go into all that as we go through the series. Stay tuned.